These notes are going to cover the states of matter along with the energy required to transition between the different states. So, what is a state? There are four classical states of matter observed in everyday life. Those are solid, liquids, gases, and neon. Those are the primary ones we're going to focus on. But there are also some non-classical states that generally occur under extreme conditions. So these extreme conditions are generally either very low energy or very, very high energy. So the very, very low energy would be at absolute zero, which is 0 Kelvin. It is a theoretical number. Scientists have gotten really, really close to observing absolute zero, but we haven't actually observed it. So at those very, very low energy levels, low temperatures, they've observed different states. And then along with very, very high energy levels, such as supernovas or like the Big Bang, they have theorized other states as well, and these are considered non-classical. So they're all dependent on the amount of energy of the particles. So depending on the amount of energy that substance has, that's going to dictate what state of matter it is in, right? And depending on the particular substance, the amount of energy required for different states may change. So we're going to start with the lowest energy state first, which is solids. So solids, they're packed close together. And the forces between the particles are strong and don't allow for free movement. We generally see these particles that are packed close together in generally some type of pattern or form, like a crystallized form. So they're not freely moving past each other, but there's still movement occurring there. They are vibrating back and forth in that strict structure. So they have a definite shape and a definite volume. And so in order to change the shape of a solid, you would have to apply a force or energy to create a change in the shape. So for example, if you have a metal spoon and you wanted to change the shape of it, you would have to apply force to bend the spoon. Generally, a substance solid form has a smaller volume than the substance's liquid form, and so what that means is that it would be more dense if you had the same amount of mass. Okay, so it would have a smaller volume, thus it would be more dense. So examples of solids that we see in nature occurring naturally are most metals. For the liquid state, particles are close and held by intermolecular forces, but have enough energy to move around freely amongst each other. Okay, so they're going to slip past each other. They can't completely break apart from each other, but they can slide past each other. They have a definite volume, but as far as shape, it doesn't have to have a definite shape. It's going to fit the shape of the container, but it is a non-compressible fluid. So we're going to talk more about fluids as we get further on in the year, but fluids are considered gases and liquids. So liquids are a non-compressible fluid. So examples of naturally occurring liquids are water at room temperature, mercury, and alcohols. And so as I was talking about solids, and that most solid substances have a smaller volume than the substances of their liquid form, ice is special. So solid water actually has more volume than the liquid form. Thus, the solid form is actually less dense than water. So that's why ice actually floats. Moving on to the gas state, there's going to be little or no intermolecular forces acting between the particles. So nothing's really holding these particles together. As when we start talking here in a little bit, we'll see that there's actually a lot more energy in this state. So it's going to have no definite shape or volume. So basically it's just going to occupy the whole container where it can find. So it wants to stretch out as far as possible from all the other particles. So it's going to fill whatever container it is held in. So examples of this are oxygen, nitrogen, and noble gases. So things like balloons, it's going to try and fill out the whole balloon depending on how much energy it has. For a plasma state, they have very high energy. And so what happens is because there's so much energy in this state, the particles actually break apart into smaller, highly charged particles. So basically the electrons get stripped. And so neon has no definite shape or volume, so it's very similar to a gas. But one distinct characteristic is that it is electrically conductive. Okay, so it doesn't need things like metals in order to conduct electricity. If you have a plasma um, substance, it can transfer electrical charge. So examples of this are neon, like neon signs, lightning, and also the cores of stars are made up of plasma. So it's a very, very high energy state. So for phase transitions, when changes, so phase transitions are just when changes from one state to another. And so during these changes, the chemical and physical properties can also change of that particular substance. And so these phase transitions can occur due to pressure, so an increase in pressure, or temperatures changes. So enthalpy is just the amount of energy in a system or a particular substance. And so if we just say the pressure is kept the constant, enthalpy change is equal to the heat energy transferred. Okay, so the more heat energy put into the system, the more enthalpy. Okay, and so as a sample is heated, the enthalpy increases and matter can undergo a phase transition or state change. So if we look at the diagram here to the right, our low energy or low enthalpy is going to be at the bottom near the solids. And then as we move up the energy chain, the enthalpy increases and it goes from liquid to gas to plasma. Okay. Sometimes enthalpy can be described as the chaos in a system as well. So there is more chaos here. There's not uniform structure or anything compared to down here. Okay, you'll see it also goes through the different names of the phase transitions, okay, between the different states of matter. Okay, so for example, a solid to a liquid is melting, a liquid to a solid is freezing. So when gases are heated to extremely high temperatures or high voltage, they can form this plasma. Okay, so generally plasma is not something that just naturally occurs very often without very, very high pressure situations. Okay, so this process is ionization. And basically, kind of like what I talked about before, it's just going to separate the electrons from the nuclei and create these charged particles. Okay, the other two that I haven't touched on yet, under low pressure conditions, some solids can undergo sublimation and change straight into a gas instead of melting. Okay, so an example of this is like dry ice. So it kind of skips that liquid stage and it just goes straight from a solid to a gas, and that's sublimation. And then on the flip side, some gases, if the pressure is raised, can change to a solid in a process called deposition. Okay, so an example of deposition would be like frost.